Sarah's. I'd like to thank Shakia Williams, David Guzman for submitting um, 3 problems that they had. So first one up was, and these are a little old, no one submitted anything for this week. So, but Shakia presented one from Keynesian Cross, and it was problem for her. Well, problem doesn't make a difference. It was the problem where you had a $50 billion transfer, and sometimes the dollar amounts differ depending on the student. But anyway, and you were supposed to say, you were given an MPC, and you're supposed to calculate the change in the planned expenditure, planned aggregate expenditure, or what I would call probably planned aggregate demand. But anyway, and we've got our 45-degree line, so I'm just drawing it right here. And equals Y. And this are expenditures. Okay, and so the start point is at 30, and the end point of the original graph is going to be at 90 and 52. Okay, just kind of put it here. So it comes through, and what's really important is it's crossing at 40 and 40. Okay, so the problem, looked a little something like this with a bunch of words at top of the page. And the idea was that the government's going to engage in transfer payments to the citizenry, give them money, basically, in essence. And your job is to calculate the shift in the planned aggregate demand or planned aggregate expenditure. Microeconomists use those terms interchangeably. Well, not necessarily interchangeably, but we'll use it interchangeably today. They mean similar things. And so you're supposed to calculate the shift in the graph, and then you're also supposed to calculate for an increase of the amount from 50 million to 100 million, what would be the amount of increase in that you could guesstimate in real GDP for what's going to happen. So the first question, let's just solve that first, is how much would real GDP increase? If the government sent stimulus checks of 100 billion instead of the original 50 billion that's proposed. So first off, we need to calculate 2 things. So first off, we're going to calculate the what the transfer multiplier is going to be. So there's a couple ways to think about this. So first off, some of you might have gone wrong. You might have put M equals 1 over 1 minus the MPC, which is equal to 1 over 1 minus 0.17, which equals to 1 over 0.83, which is approximately equal to 1.2. And so this might be the answer you got, right? And so the problem is that's not the correct answer, because you probably went through and said, okay, so now I need to increase government spending by 100 billion times 1.2, and that would be equal to 1.2 or 120 billion. Let's put it that way. Okay. So that's all I did. I took the 100 billion and I multiplied times the 1.2, and that equals out $120 billion in stimulus. The problem with that is the government sent out 100 billion, so you have to subtract the amount that government spending went out, and so that'd actually be 120 billion minus 100, which is equal to 100 billion, sorry, which is equal to 20 billion is the amount that you would see increase. Now, a lot of you probably forgot that second step, and the other side is you're using the wrong multiplier. The correct multiplier to use would have been the tax and transfer multiplier, and the tax and transfer multiplier instead is multiplier is going to be equal to MPC over 1 minus the MPC, which is equivalent to MPC over the MPS, just a FYI, just doing some different things, show you different things that we can do, which is equal to 0.17 over to 0.83, which is approximately equal to 0.2. So that's what you should have used, this multiplier. MPC over 1 minus the MPC. That's the tax and transfer multiplier. Then if you do 100 billion times 0.2, your answer is going to be equal right off the bat to $20 billion that the economy is able to grow, or real GDP is potentially able to grow. Okay. And either way, either method you used, you get $20 billion, but you have to remember that anytime there's a tax or a transfer, right, anytime that ends up happening in the economy, the government taxes you or transfers money or lowers your taxes, it's going to have to go through the washing machine twice, because consumption function is equal to aggregate demand, or sorry, autonomous consumption plus the marginal propensity to consume your disposable income. Your disposable income is actually YD is equal to, so I'll write out all the formulas I just said, MPC times YD. And YD is equal to income minus taxes plus transfers. Okay, so that's what's happening there. So if we substitute YD into here, then what's going to happen is we're going to go through the washing machine twice. And if you're concerned about how to do that, go look at the multiplier PowerPoint or give me an email. It's not too difficult, but what we're really doing is we're saying that the taxes and the transfers have to cycle through with the initial impact in the consumption function, because remember, we're looking at aggregate demand equal to C plus net private investment plus government spending. And so we're saying, look, if taxes and transfers change, then you're really hitting the multiplier here initially, and then you're hitting it here just like the government or the investment multiplier. So what's happening is taxes and transfers hit in this variable, and changes in investment and government spending just hit here. So if any of these variables change, you end up with the multiplier, which is equal to 1 over 1 minus the MPC. If they hit consumption, then you have an additional multiplier effect, which is the MPC over 1 minus the MPC. And the proof of that is online. So how do we shift this curve? All we're going to do is shift it up. Since it's half the amount, it's half of this amount, 10 million. So we want to look where the intersection of GDP is at 50. And up here should be, look at my notes, 50 as well. And so we have to draw the curve, drag it up till it's at 50 and 50, wherever that may be. So anyway, my drawing's sloppy. But you're going to shift up till 50 and 50. Okay. So that's how to do that problem. That problem's, I understand the challenge in it really is that it was a transfer as opposed to just being a straight government spending multiplier. In fact, what's interesting is when I went and checked, most of you did okay on the problem that's similar to this, where it's just government spending or private investment changing, but people didn't do as well in this problem. So it really was understanding that this was a tax or a transfer multiplier. The next problem that both of them had was with the problem, and this is a funky problem, I'm going to admit this. It has household consumer spending, and that's labeled C. And then it has on the bottom of the graph household current disposable income. And I should probably get rid of this one, YD, because it's really just, and then a graph of a consumption function, CF. So it looked like this. And then it had all of these categories, and I'll probably get rid of this one because it's purely a math problem. It doesn't really have a lot to do with the economic context. But the problem came in is it's asking you, given a set of constraints, what's a convex function versus a linear function? So first off, convex function is this, right? And so I'm not going to give you the technical math definition of a convex function, but it is one of our two nonlinear shapes. We can have convex or concave. What it means is it's nonlinear, it's not straight. So all we're checking for in the first column of numbers, where it has YD and C, and then it gives you data sets, and I'm not going to go through and write all of those out. You can look up this problem if you want. It happened to be problem 9 in income and expenditures for both of them. But what you're going to do is check and say, is this convex or concave? So let's just play with some of the data. So the first one said 10,000 and 20,000 and 15,000 and 20,000. And the problem is you have basically YD1, YD2, C1, C2. The numbers are inconsequential in this problem because with only given 2 points, you can define it as a linear line, but you can't confirm it's not a nonlinear line. To confirm linearity, this is math, not econ, as I said, probably a bad question. But to confirm linearity, you have to have 3 or more points. So you need more information to figure out whether that first one is going to be what the answer is going to be. So on the second one, and let's give myself a little more room. On the second one, we have 10,000, so 10K, 20K, and 30K. And I'm just chopping off 3 zeros to simplify my life. And then we've got 20, 21, and 23. And all of these are in thousands. And so the question is this going to be convex or linear? So if this was a linear function, for every increase in consumption, we would expect to see a corresponding increase in disposable income. And so the question is that going to be true? In fact, you could go through and just calculate out the multipliers, and you could say, okay, for this first point, 20 equals autonomous consumption plus MPC of 10. And then we can go through and we could actually solve. Let's assume that A is 0, so cross A out. And we can solve for the multiplier, and the MPC in this problem would be equal to 2, right? Marginal propensity to consume. That seems a little off, but anyway. Okay. And then let's see whether I can do this, make this work with the next one. We say 21 equals MPC 20. And this means the MPC equals 21 over 20, which approximately 1, right? Then we say for the third one, so that goes here. For the third one, it's going to be 23 equals MPC 30. And here we have 23 MPC equals 23 over 30, which is definitely less than 1. So our MPCs are going down, right? So what that's indicating is what's really happening, and if we graph these points, what we see is we end with a point at 20, let's say, 20 and 10, 21 just a little bit higher, and 20, so way out, 23, right, and way out. So if the marginal propensities consume aren't the same, right, or sorry, not the marginal propensities consume, but if the multipliers aren't the same, then we can't do anything, right? If our MPCs aren't going to be the same, then we can't do anything. So is what it is, right? And obviously if we have different MPCs at each point, then our multipliers are going to vary as well. 1 over 1 minus 2 would be negative something, you know, and obviously this is flawed because we can't really assume that A is equal to 0, but it's just a proof of concept. The other way to think about it is if you graph the points, you get a sloped line, right? And so that sloped line is convex. The next problem is obviously going to be not convex. It'll be our linear line. And here what we have is 10 over 10, 12, 20, 30, 14. So what's happening is we go up by 2 and we gain 10. We go up by 2, we gain 10. So every time we go up by something, we gain a little bit more. Let's see where our proof of concept works. 10 equals MPC 10. This is MPC equals 1. Then we have 12 equals MPC 20. MPC equals 12 over 20. Okay, which is 6/10, which equal to 0.6. Let's see. Maybe I'm just screwing this all up. Let's see. Maybe I can't do it this way. You live and learn, folks. You live and learn. Equal. Try that, tell you what this is, another 15. Using my calculator here. Well, obviously my method sucked ass, but anyway, at least this method. So those aren't the same as well, so by my previous logic it should have worked out, but it clearly doesn't, because if we plotted it wouldn't work. So obviously we need to know autonomous consumption to figure out the multiplier, but anyway, I guess we could have thrown in something. Anyway, I don't want to think about it right now. So let's think about it here. So if we plotted the points, we have C, BI, we'd end up with 10 and 10. We'd end up with a little bit higher, 12 and 20. $14 and $30. And if we connect the dots, we'd end up with a straight line, wherever that would take us. Well, I guess we could guesstimate it'd be 8 and 0. So 8 and 0, so this is 8 is our A in all likelihood. Anyway, so we've got this one. So this is going to be a straight line. If we had plotted the previous one, C, D, I, we'd end up with YD, and we'd end up with 10,000 and or 20,000 and 10,000. We'd end up with 21,000 and 20,000. We'd end up with 23,000 and 30,000. And what we can see is there's a slight slope to that line if you had graphed it, and we could impute what A would be there as well. So anyway, first one convex, second one linear. So in the last one with the multipliers, this one's considerably easier. What we have to think about is what the multiplier is. Here we don't need 3 points. All we need to do is look at the multipliers and whether the multipliers are constant. If the multiplier is constant, then you're going to end up with linear. If it's not constant, you end up with convex. So the multiplier is going to be 150, 150, 150. On the first one, that's linear. All the others, the multipliers differ just by a little bit, and we end up with convex curves. So anyway, as I said, bad question, because we probably shouldn't have, or I probably shouldn't have assigned a question that's just pure math. But so last one, a lot of you had problems with. This was depends on who you are. The number did vary on this one for both David and Shakia. But this is the one for Spencer, Tiffany, and Bob's consumption. So let's go through and just do Spencer's consumption. So we'll look at disposable income when it's at 0 and at 40,000. And we're looking at Spencer is at 30,000 when his disposable income goes to 30,000, or sorry, yeah. So when he's at disposable income of 0, then he's at 30,000. And let's just remove the zeros once again, keep it simple, add 3 zeros to the whole problem. We go to 60,000. Okay, so the way to think about this one is we've got when disposable income, C equals A plus MPC YD. And when this goes to 0, this whole thing goes to 0, and consumption equals autonomous consumption. So in this case, 30 is equal to A. So now we can use this information and put it into our next consumption function. And the next one was that at 40,000 in income, we're at 60,000 consumption. So 60 in consumption is equal to 30 plus MPC of disposable income of 60. Or sorry, 40,000 is her disposable income at that point. We're spending 60. Okay, so we take the 30 over here, we end up with 30 equals MPC of 40. We solve for the MPC equals 30 over 40, which is equivalent to 0.75. So that's not too difficult to figure out, and we can do that for all of them. And if we do that for all of them, what we find out is the Spencer MPC is equal to 0.75. Well, I'll let you do Tiffany and let you do Bob's as well. I'm just going to tell you the method to do the rest of them, the rest of the problem. So that's how you calculate their MPCs, not too difficult, just a little bit of algebra. So the next question is, and there's two ways to approach this. I approached this initially and I said, okay, there's a graphing question. We want to graph aggregate consumption to aggregate disposable income. So we want consumption versus disposable income. Okay, YD, C to YD. That's one way of doing it. The other way is we could calculate the value of the multiplier for the economy independently, right? They're really, you don't need to solve one in front of the other, right? So let's deal with solving the multiplier. There's two ways to do it. You guys can see the explanation how they did online. But one way to do it is just to take the weighted average of the multipliers that we calculated, right? So we figure there's 500,000 people at 0.75, 500,000 people at another number, and 1 million people at another number. If you take the weighted average of those three multipliers, you end up with, or sorry, the weighted average of those marginal propensities consumed, you end up with the marginal propensity consumed at the average of 0.5. So if 0.5 is the MPC, then the multiplier is equal to 1 over 1 minus the MPC, which is equal to 1 over 1 minus 0.5, which is equal to 1 over 0.5, equal to 2. And that's the answer. The multiplier is 2. Or we can solve for the whole line, and then we can solve for that equation, and then you can calculate the MPC the way we did above for calculating Spencer's MPC. So that's your choice. You can do the multiplier in front, or you can do the whole solve the line thing and then do the multiplier. My preference was to do the multiplier first. I found that easier, but you could do it either way. The explanation online shows you to calculate the line first and then do it the other way. So what are we doing in this problem? It really becomes convoluted. We want the aggregate consumption function for the whole economy. So we're trying to look for, let's call it capital C equals capital A plus MPC of the whole capital disposable income, right, for everyone. And so what we can do is we can actually go through and we calculate first is that consumption when income is 0, right? So the first thing we're going to do is consumption when income is 0, calculate for C equal A, right? So we want to know what consumption is when this number, disposable income, is equal to 0. So we're kind of crossing through this. We're going to say C equals A, assume disposable income 0, so the marginal propensity consumed doesn't matter. What we're really doing is calculate the endpoint. And so if we do that, then we're going to say that C is really equal to $30,000 or 30 times 500,000 people, so 500, plus, and this could be the tricky part, who is what? And so what I'm going to tell you is there's 500,000 big spenders. Those are the people that have high autonomous consumption. There's 500,000 big savers. Those are the people with low autonomous consumption. And the people in the middle are 1 million, right? And so then we have $20,000 times 1 million, which if we drop off 3 zeros is 1,000. Then we take that plus 10 times 500 again, because we're dropping off 3 zeros. We get our number, which is going to be when we add back in the 3 zeros, right? You multiply this all out, you end up with $40 billion. Because I did all of this multiplied times 1,000. Okay, so you take all of that, multiply times 1,000. And we end up with 40 billion, which is our endpoint here. Now on the other side, so that's our one endpoint. Now on the other side, we want to figure out, because the graph tells us when disposable income is 200 billion. Okay, so we want to figure out what's our endpoint when we're at this 200 billion mark, right? So where are we going to intersect that vertical dotted line? And the way to do that is we calculate the spending per individual. That's how the problem shows you, and that's probably the easiest solution. So to calculate spending per individual, first off, we have to say, okay, if there's 200 billion in disposable income, what's the average amount of income per person, the average amount of disposable income? If you take 200 billion and divide it by 2 million, you end up with average disposable income per person in this economy is equal to 200, or sorry, not 200, $100,000. So that's your trick, right? So you're going to say 200 billion is your disposable income in the aggregate. On average, that means each person has 100,000. And so what we're going to go through is for Spencer, Tiffany, and Bob, what do they spend? So let's do it for Spencer, because I can give you the MPCs for Tiffany or Bob. So for Spencer, what we can say is when his income, so we're calculating his consumption, his aggregate expenditure is going to be, or his atomic consumption is going to be 30 plus 0.75 is his MPC times 100,000 or 100. So we end up with his consumption is equal to 30 plus 75. That means consumption is equal to $105. So now we know his consumption is equal to $105. This for Spencer. And now we would have to figure out for Bob and for, or sorry, yeah, Bob and Tiffany what it is. Then we take this average consumption, okay, and we multiply times the population. And so we say, okay, well, in Spencer's, there's 500,000 of them, so we do 500,000. And here I'll add in the zeros, times 105,000 in spending. And that tells us for people like Spencer what their aggregate, what their consumption is going to be at that level. So where we'll be on this graph. We're going to do this for people like Bob and people like Tiffany, and then we're going to add it together, and what we're going to end up with, what you should end up with if you do it right, is 140. We connect the dots, and so we're at 40 and 0 and 140 and 200, and this ends up being our consumption function. Then you could take the slope between these 2 points and calculate the multiplier, which should be equal to the 2 that we calculated before. So this is how to do the problems. They were challenging problems. The exam is nowhere near as difficult on this material as the problems. Hopefully you guys understand that. The problems are meant to be challenging. You know, they're meant to make you struggle and think and show you what you know, show you maybe more importantly what you don't know. But hopefully they weren't too bad. It looked like for the most part it was the normal ratio, maybe a little higher than normal. About a third of the problems, quarter of the problems, third of the problems for most people were difficult. In fact, you know, for a few of the people I looked at, the problems weren't even that difficult at all. I think these were the only 2 to 3 problems that were difficult for many of you. So in that case, out of 13, that's 20, 30% of the problems were hard. The rest of the problems, you know, were fairly easy peasy, at least half of them. So anyway, they were meant to be difficult, meant to be challenging, nowhere near as difficult on the exam though. So if you have any other questions, feel free to always call, feel free to always text, feel free to email. If I happen to have forgotten anything or not replied to an email or text, I'm getting a lot of them this time of year. So please don't feel like you're bothering me. Ask again, okay? I'll talk to you later. Thanks. Bye.